Good morning, good afternoon, good evening. Welcome to the Rhize podcast. My name is David Schultz, and today we're going to be talking a little bit about the Manufacturing Data Hub. We're going to continue to draw on our conversation around the unified namespace, as well as the Uber broker. And we're even going to talk a little bit about some of the elements of the ISA 95 standard, going back to our first two episodes of the podcast. It's going to contain some of the same elements. So we're going to talk a little bit about composition versus inheritance. We're going to talk a little bit about orchestration versus choreography. And we're even going to get in to talk a little bit about event-driven architecture. But before we get to this, let's introduce our two guests. I am joined today by Geoff Nunan and Andy German. So Geoff, take a moment. And for people who don't know you, make a quick introduction. Tell us a little bit about who you are.
Yeah, thanks, David. My name's Geoff, and I'm the co-founder and CTO of Rhize. I've been doing control systems and manufacturing software since 1994, so 30 years this year. I'm obviously Australian, as you will tell from the accent. But have been doing this around the world now for many years. So yeah, excited to be here and excited for the conversation.
Excellent. So Andy, not an Aussie, but a Brit. So let's learn a little bit about you.
Yeah, absolutely. Yeah, I'm Andy. I'm, as you mentioned, I'm based out of the UK, somewhere close to Manchester, which a town some people may recognise. Mainly football followers, I think. I've been with Rhize for 3 years now, something like that, but a much longer history. I've been around for about 25 years in this space. The first half of that mostly in software engineering roles, and more recently in a kind of architecture / leadership roles. So yeah, it makes me feel old when I say 25 years. So I'll allow you to take over, Dave.
I've been doing it for 25 years as well, so I totally get it, but I still feel young. It's like when I say the young people, I sometimes still think of me in that as well. So Andy, Geoff, welcome to the podcast. Looking forward to this conversation. Thanks for joining. So I want to do a quick level set. Just going back to a couple of our previous episodes. One was around the unified namespace. And the purpose of that podcast was let's talk a little bit about what is the definition, let's socialize, just so there's a good understanding and agreed set of terms there. So, where we landed in that, it's an approach for an event-driven architecture that uses a pub/sub technology like a broker. And it also applies a data ops tool that define the data models, as well as the topics where that data will be exchanged. And one of the things that we all agreed on is that that's a pretty generic definition, but there's not a lot of, but there isn't a storage in that becomes one of the nodes within that ecosystem. And that's a good segue into when we were talking about the, Rick Bellata, what he calls his Uber broker. That's just his, I think his code name for what it is that he's trying to build. Some of the things that the UNS doesn't offer that the Uber broker tries to solve is, of course, first I need to have the ability I need to be able to call functions against some sort of endpoint. I need to be able to call methods on that. There needs to be the ability to query the UNS, and also I need to start containing and having some metadata in that. And bringing all those things together, we realize there's a few more parts that are going to be part of it. UNS really just creates that core, architecture, that core ecosystem. And then we're going to expand that. So we now have the ability to get back to the data. That's really what's important to us is how do we understand what's actually happening on our plant floor and the ability to interrogate and analyze and do all the things there with that. So with that, just a little bit about the UNS and the so-called Uber broker. Let's talk a little bit about, well, what's a manufacturing data hub then? Where is that different? So, my position is that a data hub contains a UNS. I would say it contains the Uber broker or has elements of that. But, Geoff, can you tell us a little bit about, when somebody asks you what's a manufacturing data hub, what do you tell them?
Yeah, great question. And obviously one that we get asked a lot. So if we start with that context of a UNS being, that pub/sub broker and the unified topic namespace, it's really a mechanism for communicating between systems, right? It's an integration pattern. It's somewhere that you can go and get the current context of whatever is in there. But it's also the mechanism for systems to communicate to each other. So then you've got, what Rick Bellotta was talking about, which is, okay, but I need to be able to kind of do a little bit more than that. I need to be able to separate things out into different topics. I might need to call functions. I might need to be able to query both that kind of current state, but also history, which means that history is being stored somewhere, right? So a manufacturing data hub is, the UNS is kind of if we think of it as an onion, it's the layer around the outside. It's how systems communicate. But then inside that, you've got functions, and inside that, you've got storage in there. So you've got a database, you've got a schema that you're working with, you've got an application logic layer to have functions, and you can integrate that in with all the things that are connected to your UNS. So it's an application that kind of sits inside the context of a UNS. So it's a unified application layer, if you like. How it came about, really from two different places. So as I said, I've been working in this industry for 30 years this year. And many years ago, I did a lot of MES, manufacturing execution system, implementations using off-the-shelf MES software. And I've done a lot of those over the years, and really had just gotten frustrated with how difficult it had become to do quite simple things. Always battling against the hard constraints of an off-the-shelf system to do whatever the customer or the business wanted to do. It was never a fantastic fit between the requirements and the capabilities of the platform. Maybe you get 80%, but then the other 20% of the requirements would take 80% of the time to build. So we kind of come up with the concept of saying, well, what if we followed the pattern that exists in other industries of a headless pattern, of having the hard computer sciencey part done in a platform, but then being able to leverage low-code front-end application development tools to be able to really do the application development bit a whole lot simpler. So it came from that, and the other set of requirements, which were seeing a lot of data scientists come into manufacturing and spending a whole bunch of their time doing the tedious bit of collecting and contextualizing and cleaning the data, so that the data science team could actually then do the magic, the data science bit. And so these two things kind of go together with, okay, I need a platform that can kind of collect and contextualize and cleanse this data, so that I can leverage low-code front-end tools to build applications. But I also need to be able to stream that out in that nice, clean, contextualized data set to enable the AI and the data science teams to be a whole lot more efficient, to save them from 80% of the data collecting and cleansing work, be able to stream them good data. So it really came from those two needs that we said, well, okay, if we were to take the best of modern technology and put it together, what would it look like to solve those two problems? And the answer was, well, it's kind of like a UNS with some storage and with an application layer to be able to kind of do the application functions and the stream processing and the other bits to it. And that's really what a manufacturing data hub is.
Yeah, excellent. And that's, we talk a lot about, don't buy an MES, build your MES. So it sounds like, well, you went and actually built your own MES. And of course, naturally the next thing you do is, well, now I'm going to make this, commercially available to other things. But I think what's different here is that it's much like UNS. There's an approach to how you're doing it. There are some, as we define a manufacturing data hub, there's some elements to it that need to be there. And of course, within the Rhize platform itself, there's some services that need to run in there to make all of this stuff happen. So, with that, Andy, let's just talk a little bit about some of those services that are there. So that, there's an edge agent, we have a rules engine, there's a workflow engine. We utilize a graph database, or a knowledge graph is another term that's used to describe that. And of course, there's a queryable endpoint. So let's just talk a little bit about some of the services that really you would need, generically speaking, for a manufacturing data hub, but specifically to the Rhize manufacturing data hub platform. So what's the role of the edge agent? What is it doing?
Okay, so in broad terms, what we're generally trying to do with any of our project implementations is bring data in and land it into a persistence layer, generally speaking, into the graph, and make sure it goes in the right place, as it comes in. So our working back from the graph database is a persistent schema. It's an ISO 95 schema. We've got the whole object model really within our graph database, and we're looking to land data from the process, and also put definition data and that kind of thing into the graph database, which sets us up ready to respond to events that we've got coming in from the shop floor. So that there are kind of I normally describe it as sort of two types or two streams of data that we get coming in from the shop floor. We have what I would describe as telemetry data, process data, or tag data, and that kind of thing. And that would come in, generally speaking, we will be abstracted from the low-level protocol layer. So we're not talking necessarily to PLCs. We're normally looking to connect to an OPC UA server, or an MQTT, or some other broker, something that can provide our data basically for telemetry purposes on a kind of a topic structure, if you like. So our edge agent is the part that takes care of that. So the edge agent, broadly speaking, provides the connectivity layer to bring the data in. It provides a bit of filtering and that first layer of contextualization. So the edge agent is able to determine through its configuration if a particular tag value comes in from the process, then we're going to land that data on the right piece of equipment. So I would say that the edge agent provides us with this stream of tag values and allows us to position the data alongside the correct equipment in a time series context and in a broker context as well, so that the data becomes available sort of in its current state via subscription to the broker, and also is queryable because the edge agent has pushed that data through a sequence of steps that allows the data to arrive down in the time series layer. So we've got sort of our ingress processing for tag data also includes a rule engine. So that's another one of the services that we've got in the stack there. And what we do with the rule engine, again, it's a configuration piece. We configure rules that will effectively sit on a tag or a collection of tags on a particular type of equipment, a particular equipment class. And we'll look at those values coming in from the process, and we're able to do a kind of simple filtering, simple arithmetic, simple evaluation on those discrete values, and we can decide whether we're going to produce the second type of event, which I would determine as being a complex event. So something's happened. So what the rule engine does is it allows us to look at a stream of data coming in from the process that's coming off a particular piece of equipment, and then you infer from that data whether something significant has happened. And the use cases are reasonably simple. If we see that the order number or the product number or a barcode scan has changed, the material, that means that the material may have changed. So that may be an event like the order has changed on a particular piece of equipment. Or we may see the run speed go to a certain value, which is higher than a predetermined threshold value. So we now know that equipment is running at full speed, and we know that equipment is now out of setup, for example. So our rule engine allows us to sort of interpret a raw stream of data coming in from the equipment, and allows us to create or infer more complex events from that. And what the rule engine does is, okay, I've found something interesting now on our process. What are we going to do with this? So at that point, the rule engine will bundle the context that's available at that moment in time, and can be configured to push the event details across to our workflow engine, and our workflow engine can be used to compose a sequence of business logic effectively, which will allow us to persist something more complicated and more sophisticated into the database, and can at that stage be used to resolve some of the relationships that we've got. And this is where it becomes a little bit more abstract, because when you're talking about workflows and rules and events and relationships and that kind of thing, this is the point at which you can kind of get lost, really, and find yourself really just talking about concepts and abstractions rather than actual things. But to give you a concrete example of, referencing what I was saying before, if we can detect that the process of values have changed in such a way that we know a new order is running on a piece of equipment, then what we can do is access our graph, run a couple of queries to find out what the next order is, for example, or if there are any orders in the system that match the conditions that we've just found out, and we can head into the graph and start performing mutations to say that a new order has started at this time, and we know that this user was logged onto the line because we got some other context, and we can then start to create new context for the next bunch of data that's coming in from the line. So we may create a window of records for job responses, for example, to use the ISO 95 terminology. And now all the new process data that's coming in will be streamed into a specific job response context. And the job response will have a relationship in our graph to a process segment definition or an operations segment definition or a scheduled order and that kind of thing. So it's this kind of chain of events that happens that allows us to explore and understand the contextualization and kind of enrich what's happening and persist that into our graph layer. So that's one part of it. The other side of that, which I've not really touched on, is I'm only talking about equipment tag data there. I'm only talking about process values, but the other interesting events that we can have coming through our system are complex events that come in from other systems or other actors within the environment. So it could be that an SAP order is released, for example, or it could be that an MES system, maybe we're not acting as the MES in this case, another MES system emits an event that says an order stopped or an order started or a machine has gone down or something like that. So alongside the raw data that we're ingesting into the platform, we're also ingesting these more complex events that have themselves got embedded relationships within the data that's being published. So an SAP order, for example, is a very complex object often, and it will, there'll be an order number there, there'll be a bunch of materials to be consumed, materials to be produced, and that kind of thing. So we're processing that kind of data, not through the rule engine, but through our workflow engine in a kind of a slightly more sophisticated way. But and the goal really here is to make sure that we're persisting data into the right place. So we're persisting data into time series, but we're also persisting these complex objects in the graph so that they can be queried at a later point. So we're trying to sort of build up a full picture of what's going on in the manufacturing environment in graph and time series, so that this data can be consumed in a number of different ways later on. And the last thing you mentioned when you sort of introduced me to this topic was to sort of say, this all comes through, this is all accessible through a query endpoint, and our query endpoint is a GraphQL endpoint that allows a consumer to consume the data that we've been persisting either via query, so you can hit our GraphQL endpoint and look at the job orders that are running or the job orders that have run on a line. You can look at the current process values through the GraphQL endpoint. And you can also query, we federate our time series database. So you can also get history values right there from, within the middle of a query within the GraphQL. And because we've got quite a very convenient architecture within Rhize, we've got the NATS broker embedded, we've got the graph embedded, we've got the time series embedded there, and quite well integrated together. We've also got quite a number of options for getting at the data via subscription as well. So we've got a kind of a natural pub sub option. If for example, we're starting, an order has been started, it's a fairly trivial exercise to get Rhize set up so that we emit that event and make that available either through our broker, through MQTT, or maybe we push that onto a queue in Kafka or something like that. So when the data comes in and gets persisted, we've got a bunch of kind of convenient methods for not only persisting that data, but allowing the data to bounce back out of the platform and into other platforms and could be published to other interested parties. And I think the difference is that what we're doing is we're reacting to the data as it gets persisted into the knowledge graph, and the moment after it's been persisted into the knowledge graph, the data then still becomes available for pub sub, but that kind of next stage of pub sub where it's happening from within the graph gives us the convenient access to relationships. So I think a long explanation there, David, but I think that kind of tries to sum up some of the services that we've got in the platform and what they're trying to do for the use cases that we're interested in.
Yeah, awesome. There's certainly a lot in there. So let me see if I understand, and I'll relate what I just heard back to you. So, I would think that the Edge agent is, in many ways, this is what we're going to call the UNS piece of the manufacturing data hub. This is all that Edge data. Ideally, it's been, contextualized and normalized in some way, but that's mostly we're going to notice something changed down at the PLC or in the SCADA layer. Something is occurring there. Is that a fair comparison to the Edge agent?
It's correct, yeah. And the Edge agent's responsible for bringing that in. Yeah.
Okay. Then the rule engine
it's also doing a bit of
Geoff.
It's also doing a bit of what Rick Bellotta was describing in the Uber broker, which is republishing or breaking out a message and publishing it into different bits. So what the Edge agent is doing there is taking a sensor and putting it in the context of your UNS equipment hierarchy. So it's saying, let's say we've got a temperature sensor, which might be temperature sensor 1 in the PLC, or coming through as a bit of information like that. It will come into the through the Edge agent as temperature sensor 1, but it will get republished into the UNS as equipment. Maybe it's injection molding machine, input temperature. So it's doing the data collection bit and the pub sub broker bit, but it's also binding into the standardized model. So often, I know people kind of tend to have in the UNS structures kind of different areas for sensor data that then gets republished into the kind of unified equipment hierarchy structure. The Edge agent is doing that bit as well, and that republishing and the breaking out of one message into multiple messages and that sort of stuff.
Yeah, I mean, to me, that's that rule engine is sometimes the data I'm getting at the edge. I'm not really able to determine what's actually happening here. So that's when I create this rule engine to say, that temperature sensor changed, or perhaps the state of a machine changed. But based on its relationship to other data, that's what the rule engine is doing. Is this thing changed? What does that mean? It means this is that outcome that's there. Now I can apply the rule to it, and it's that republish of it's temperature sensor one. Now it's it's a piece of equipment, and something is occurring there. So
Well,
is that correct?
yeah, not quite, not quite.
Okay.
So that's all in the edge agent. So yeah, this temperature's come in, and we're republishing that, putting that in context, and saying, okay, that's actually injection molding machine input temperature. What the rule engine is doing is applying rules to that, and those rules are data rules. So okay, we receive the temperature, but is that temperature good or bad? Is it too high? Is it too low? So the rule engine is actually somewhere where you could apply limits to the temperature and then republish an event that says, actually, we've had an over temperature event here. So it's putting that temperature in the context of other streams of data or other topics, and allowing you to run an expression across multiple topics to determine whether something interesting has happened.
Okay, perfect. Well, thanks for that explanation, because I definitely misunderstood there. So great clarification. So now once we have the rule and we've just said, yep, this is proper, this is good. Now we're going to instantiate a workflow, and to me, this is really where it gets hard in the manufacturing execution, or the manufacturing operations management, or what are all the steps that actually need to occur there in this workflow. It could be just some movement of data, but this workflow could also be, there's going to be some interactions with other systems that need to occur in the traditional how we look at workflow. Is ours doing the same thing there as well?
Yeah, I'll jump in. I use an example of most people can kind of relate to, which is their car. And if we were to run a manufacturing data hub for our car, we would have an edge agent collecting the data. We might have a rule that's looking at the engine temperature and monitoring the engine temperature between sort of upper and lower limits. And maybe we've got that rule set up so that if the engine gets too hot, I want to trigger a workflow. And the workflow might be automatically go and book my car into the mechanic and have it checked out. So the workflow is triggered by an event of some sort, but is a series of activity or series of actions that can happen in response to that event. So that can be doing some sort of data pipeline, or it can be doing something that's more of a long-running workflow, like I'm going to book my car in for a service at the mechanic, and then all the steps of paying for that and picking it up afterwards, and all of the sequence of actions that happen after I book my car in for a service.
Okay, perfect. And I think the graph database, and this is when I first was introduced to what Rhize is doing. This to me is along with these others, this is the value, because I'm predefining all the relationships, and I've also built it against a schema that is a widely accepted standard. But it's a knowledge graph in the sense that we're not constrained to a relational database, which has existed for a long time. And that's the whole point of every time we're writing, making these mutations, as it's called, within a graph database. It's the data that's written in there is written in a way that it's already predetermined, and there's rules for what this data needs to look like before we can run that mutation or make the change there. So a lot of it in these previous steps are just making sure that, okay, we're getting it all ready to go, then we're going to pump it into the graph. And the beauty is that it's a knowledge graph, and I'm not constrained to that relationship. Is that fair?
Yeah, I think that's fair. I think our graph database and the way that we've gone about implementing our graph database emphasizes a schema up front. So we're not emphasizing schema on write, which is kind of the way that a lot of graph databases assume they might be used. We've got this sort of flexibility on mutation that allows you to push the relationships, as you push the data, and allow those relationships to evolve. We can do that with our graph database, but what we've actually done for the specific sort of ISO 95 ontology part of the database is that we've predefined the schema. We've pre-codified all the relationships between all the objects that ISO 95 exposes as part of that standard. And so when you push data into our manufacturing knowledge graph, you need to respect the relationships that have already been pre-established within that schema. So that gives you a way to express with ISO 95, and it allows you to know in advance what the relationships should be and what the queries back out of that database should be based on the ontology, on the schema that's defined in ISO 95, which is difficult to do in anything other than a graph database, really, because the complexity of the ISO 95, it's an object model. It's a quite a complicated object model with a lot of recursion. So when you really want to access the knowledge graph, because of the, in some areas, hierarchical nature of ISO 95, and the long running relationships, from materials all the way through to equipment, materials through to schedules, that kind of thing. There's often a real need to traverse and recurse those data objects when you're accessing that data. And I think you can only really do that with a graph database. I think that heavy recursion and traversing and joining across entities gets wildly complicated when you're working with SQL Server, just because of any SQL database, just because of the object relational impedance, which is probably a bit too technical, but that's one of the advantages that we've got with graph.
I was just going to say, I've run into those queries where you're joining across 10 different tables just so you can get that data back. And after that, I think it's where you really start to bog down the system, especially if 20 people are trying to run a similar type point. But, querying the data, that's important. We use a GraphQL API. It allows people to access not only the graph database, but you can bring in other data as well. It's not purely just limited to. And I think this is really when we were talking about the Uber broker, is that having that common endpoint, that there's going to be all these various nodes that are going to exist within that ecosystem. And if I want to get data out of them, as we just look at it from the context of the UNS, I have to go to all of those various nodes, where in this case, I can have a common node that will, if it makes sense or if it's relevant, I can have that GraphQL API. Now I can maybe have it hit those other services, if it's relevant, where it's time series data or some data warehouse information we need to bring back. So I think, to me, just having that open, that queryable, it's an open, GraphQL API that we're using for that. So it's, building it all in, and now it gives us the ability to access the data very quickly. And then the way you ask it the questions, that's already been predefined. Is that right?
That's exactly right. And there's something else with the way that GraphQL works, which makes it particularly convenient compared to other ways of expressing APIs. So if, for example, you're using a REST API, a very basic REST API, you would tend to have an object on an endpoint. So your URL would determine, generally speaking, which object that you're going to access. So you might have, my API /version1/products, and then some parameters that allow you to sort of supply, which product you're interested in. And when you hit that product endpoint, which is effectively like a path, it's just like a path on in Windows Explorer, for example. When you hit that endpoint, you're going to get the files that exist in that folder. That's kind of, that it's analogous to a file system in a way. And that's not the whole story. I'm just trying to find an analogy. But if you're accessing multiple entities, so if you're accessing products, but you're also accessing orders and materials, raw materials, other entities or other objects that are sort of hidden behind this database layer, What you end up having to do at the client side of things, if you're interested in multiple objects, you've got to make multiple calls out to those to that REST API, and you're going to bring those objects back in, and in your client code, in memory, with whatever system you're working in, you've got to rebuild the relationships at runtime between those objects when you've queried for them, which kind of pulls a lot of it limits your ability to manage complex object relationships at the client side, because it's cognitively difficult and hard to code for, that kind of thing. And it's almost exactly the same problem if you're working with a broker. If you're working with an MQTT broker, the topic structure defines part of the data, really. So your equipment hierarchy is defined by the path, the topic structure, that kind of thing. So if you want to try to make relationships or understand how things in different parts of the broker are related, then you've got to do multiple subscriptions, and then there's a temporal element to the way that you deal with the data that then arrives that allows you to connect that data back up, which can be, it's doable. It works because we've got this idea that we can democratize data with an MQTT subscription or a REST endpoint. But we do run into this next problem of rebuilding relationships on the client side, and you don't get that with GraphQL. When you query, you put your query together and you can traverse and recurse across these objects that are available in the graph. But when you get your data back, the relationships are in place. They're embedded in the JSON response that you've got back. So there's a convenience there for the front end developer, or even for the back end developer who's putting together business logic, that you can choose the data you want at query time, bring it back in a predefined structure with the relationships in place, and then you can do the work on that data. So it avoids the need for having kind of orchestration of multiple different object types and many visits to the database, because you're getting it in one hit on a single endpoint.
Thank you for watching the Rhize Up Podcast, Episode 5. There's no outro done by David in this video because the next few episodes will be a continuation of the same conversation. Thanks for watching.